Hello everybody. So today I'm going to show you a tutorial about Chemdraw. Chemdraw is a very important software that is used by chemists to draw the chemical structure. So everything that I have shown you until now, all the rules are integrated in the software. Toutes les règles scientifiques, chimiques, que ce soit les règles de liaison, la conjugaison, le nombre d'électrons de valence sont intégrés dans le software. So Chemdraw is a very interesting compound software and is the base of what people use to draw their compounds and paste it in their publication. En fait, il est utilisé pour dessiner les structures chimiques que vous voyez dans les publications, mais aussi d'exporter dans des bases de données. They are also used to be exported on the database. So what you can see first, file, you can type file and a new document. New document is to open a new document, obviously. Open is to export. You can open and save your file. You can export like a document with a different format. You can export different templates. You can see the name, advanced amino acid for peptides, bicycles, conformers, nanotubes, polyhedra, peptides, RNA, store center, supramolecules. Okay, supramolecules is part of supramolecular chemistry. You can export some function, different function, and different pathway. Okay, for example, you can export, and you can draw some simple pathway. You can draw is for also drawing. And also drawing some compounds. So you can draw some figures, okay, and you can draw some different files. I'll come back to new. So you can, like, if you close here, you have different sub. So I continue the recording. Just here, this carbon, you can do a lot of things. Okay, you can go to structure to check if the geometry is precise. Okay. You can go to clean check structure, no problem, but you have to make sure that the structure is clean. That means it respect all the geometry. So ça permet de contrôler toute la géométrie. You always use that. Check structure, then clean up structure. Okay. That's all. Now it's fine. One more thing, if you go to view, so I just repeat again. On view, you can type on the structure. You can show analysis and paste. What that means, you can edit the analytical data. Now it's fine. So you can see that this carbon has 10 carbon and 14 hydrogen. It means that Chemdraw. Bon, bonjour à tous. En fait, je comprends pourquoi. I understand. So this is the compound that we have been drawing. You have to know that when you draw the Chemdraw, always omit the hydrogen and the point are carbon. So this is a carbon and this is hydrogen that are omitted. So I'm going to explain what that means. So one thing is showing you the stereochemistry. Here you have a hydrogen. You must draw that it is a hydrogen. It's omitted, but it's here. Here you have two hydrogen. Carbon has always 4 neighbors, or unless it's a double bond or triple bond. So here. Hydrogen. Okay, you have to check whether you have. This one is not linked, so this is a mistake. You type on A, you click on A, then you click on the atom that you want to change. Then you can edit the atom. So if I want a bromine, I can type BR. You type the l'abbreviation of the symbol. On tape l'abréviation du symbole atomique, okay? If I want hydrogen, I type hydrogen. I can type even CH3. En fait, on peut utiliser tous les groupes génériques. So here you can, it's a formula that means the CH3. But if you want to keep the free, which is wrong in terms of chemistry, you can put it here. You peut en mettre en puissance. You can do what you want, but for chemistry, we use the first one, CH2, the first formula, okay? This one is subscript, en fait, that's superscript, okay? Et ici, on peut changer la couleur. For example, I want to change the color of this one. I can put it in red, okay? Here. I can select with the lasso, this lasso, or this one, no matter, as long as this one. No matter, I can put one part in blue, for example, okay? So you can select and draw the color. Okay, this one is red. So I just finished drawing the compounds. So this is something very, very nice and very important. So now it's complete, okay? Now the compound of, okay, let's say it's H, okay? So this one equal and you have to be careful about one thing. If you omit, if you keep it like this with Chemdraw, that's with Chemdraw. That's with Chemdraw. With Chemdraw, see, if you keep this position like this, it could mean that it's any atom, okay? With Chemdraw, you need to draw it means that it's an upward position, okay? That means if you keep it this CH3 here, this one, this is CH. For Chemdraw, it's a C, okay? That means any atom, I can add any atom or any bonds has a name in a neighbor, okay? But in a Chemdraw, if you don't show, that means it's a CH3, okay? Carbon 1, I show you, C1, okay, this is C1. That means for Chemdraw, if you don't show, if you don't draw, if you keep it as a point, it's a CH3. It's a CH3 like this. So on met en indice le nombre d'hydrogène. The number of hydrogen should be like this, subscript. Okay. And Chemdraw C1, he will look it has an open position. Any atom can be there, anything. So it could be, for example, C. I don't know. Just give an example. CH3. It could be CH bromine. It could be even a phenyl. Okay. It could be a phenyl, a carbon here. It could be anything you want, okay? This is the difference, a big difference that you should keep in mind. Very, very important. That's the difference between them. So now I continue on Chemdraw. So what I mean, this structure equal this one with Chemdraw. This one. Okay. I'm using the eraser. J'efface. Ok. Il faut cliquer sur l'atome. You have to click at the atom when you want to delete, like this. Okay, now this one equal this one with Chemdraw. Okay, this one equal this one with Chemdraw. But with Schaffender, this one, it means here you can add many. It's open. Open, that means I can add all the possibilities. That means I can add a phenyl here. I can even add a phenyl. Okay, so you have to specify with Chemdraw, Schaffender, all the details. So, but if I show like this, he will think, oh, I don't show this one, he will add the stereochemistry. Okay. One more thing. Just I want to prove you that it's the same. Je veux vous prouver que c'est la même chose with the analytical toolbar. You go to view, you show analysis. So you see this one, paste. Okay, it's coming, paste. Bon, on a un petit problème de, we have a small problem of, okay, you see here, this one, the molecular weight, the exact mass and molecular weight are close. Exact mass is, you include the isotope. On a des isotopes, okay? On a des isotopes ici. You have the isotope and the mass is here. 100% and 1 small percent of isotopes, les isotopes, ok? Ça, c'est la masse exacte, en fait, avec tout le profil. This is the profile by mass. I just remind you that we check everything depending on the mass and the NMR, most of the time. NMR, analysis. On analyse les produits chimiques. Mainly, ok, il n'y a pas que ça. Analysis. So I continue the work. Just to tell you that this is a stereochemistry, okay? Stereochemistry is here. Chemistry is shown. When you have this one, okay? It's named wedges bond. En fait, ça vient vers upper plane. It's coming upper the plane, coming to us. And this one, or this one, it's the same. I mean, sorry, this one also are the same, okay? And this one, when it's dashed, quand c'est haché comme ça, in triangle, okay? But this one is different. This one is different. That means no matter. It's like a dative bond, okay? This one is dative bond. So we continue the work. So about the bond here, you see this one, the edge, it means, okay, you can, let's redraw it. It's a stereochemistry, c'est la stereochimie. That means when it's like this upper is upper the plane, okay? And this one, that means it's below the plane. The plane is like this bond, okay? This bond, okay? That means here the hydrogens is like a triangle, okay? But if you use like a dash point like this, it means that it's a hydrogen bond. Hydrogen bonds, okay? That's something very important to know. Les liaisons datives et les liaisons hydrogènes. Voilà. Donc c'est, then you can choose to, you can increase or decrease. You can make it bold, okay, souligner, or you can change the color here. You can change the color. Okay, so upper plane, below the plane. So this is the stereochemistry. So this compound equal this one, okay? How, as I was saying, in Chemdraw, it omit the hydrogen and the carbon. A carbon is like a point, is a point. This point is carbon. And here you think that it omit the hydrogen, that means you have two hydrogen. And below, the one that is below, it's a hydrogen, okay? So it gives you the stereochemistry. Stereochemistry is very, very important. So I was trying to prove that it's the same mass. I want to prove you that what I'm saying is right. See, so you paste, and it's the same between this one, is the same, okay? The exact mass, it's with the isotopes. And we, for the analysis, we use NMR and the mass. For as a chemist, pour un chimiste, on utilise la RMN et la masse pour caractériser le produit. We use NMR and the mass to characterize our compounds. Okay, and here you have some analytical data. On a des outils analytiques comme the weight, okay, the molecular weight, the element analysis, the percentage of carbon versus hydrogen, and you can so I show you one thing. Uh, on peut faire plein de choses, on pouvait faire plein de choses. Hein. You can come back and give you some example, because examples are very interesting. You can go here, view. I showed you what is view. If you don't know, for example, si vous connaissez pas la molécule, le nom de la molécule, if you don't know the name of this compound, or it is the same, okay? This one is more detailed, and this one is the generic. But that, keep in mind, very, very important. With Shelf-Under, if you draw that, that means each position is open. What that means open, it can be any atom. Any atom. Open position, it means can be linked to any atoms and or bonds cycles. Okay, that means open. You can add whatever you want at this position, okay, with Shelf-Under. But with Chemdraw, when you draw like this, it's equal to that. That's very important to understand. So as we need to think like Shelf-Under, okay, we need to think like Shelf-Under. That means when you keep open, we can say, hey, find me a molecule that is with this skeleton. En fait, Shelf-Under just will focus on the skeleton and find you the same skeleton, no matter the molecule, okay? But Chemdraw, if you show that, it will think that it's a molecule, okay? It will give you the data. Then you can go to select, okay? You always select the lasso, the first lasso, then you select okay, if you want to change one atom, I said, or you use A to change it, or you can, for example, I had the zinc here, okay? No matter, you can structure toolbar. Where is the structure view? Structural toolbar. Analysis. So analysis, it gives you the properties of your compound. What I want is like some data. Structure toolbar. Here you can, if you don't know the name of a compound, you draw it. Okay, it gives you like the name. Poof. Why is the name? Trust me. Oh, it's maybe heavy. So maybe it's because of there's a small bag. Normally, poof, structure to name. Ah, ça marche pas. Pourquoi? You can type the name, but I don't know. Normally, I show you it was working before all the analytical data. Maintenant, vous avez la RMN, ok? La RMN, c'est the structure, the chemical structure of, it's a fingerprint of your compound. Each compound has one fingerprint, c'est l'empreinte digitale. But I don't know why it's not showing. If you want the name, you can go to structure. You can go, it's similar here, okay? But text curve. So you can change the atom properties here. You can implicit hydrogens. Yeah, here you can do it. If you want to show the hydrogen, you can change it, okay? Si vous voulez, if you want to show the hydrogen, non, ça marche. Why it doesn't work? Text. Atom properties. Allowed. Implicit hydrogens. You can add the stoichiometry. Here you have the stoichiometry, but it's a bit abusive here. Yeah. Normally, I don't know why maybe it's this. Why it's not showing the? You go to structure view. You can go to structure. Okay, check structure. You always do that. It means there is no problem in the structure. But for example, I don't respect. Okay, I draw it like this. Imagine you don't respect the geometry. Okay, I draw it like this. It's not clean. Okay, you go to clean up structure, and clean up structure will give you the right geometry. Okay, so this one equal this one. Okay, we said it. So for example, I take two hydrogen and I don't respect, or I want to clean it. You go to structure, you check. There's no problem because, but there's a problem with the geometry. Okay, because we said that it should be 100, and now it's clean. Okay, it's clean. But I don't like one thing. You should show one of the two bonds should be up. Okay, that means this one is up. Up. C'est la CH3 is coming to us. This H is below. Okay. One more thing, if you want to draw a cycle, you have a triple bond, and you can, if you want to add one oxygen, you click on one. You choose A, you click on the atom, you type O. Okay. Then, if you want 5-member ring, 6-member ring, 5-member ring, 7-member ring, boat, or this boat. What you can do, if you want to say, hey, I want a polymère, un polymère, et vous voulez dire qu'en fait il y en a 1000, j'ai ce motif là, par exemple on peut dire, et c'est comme ça qu'on dessine les polymères, for polymer chemistry, par exemple on veut ce motif, et on veut dire que le premier ça commence par un oxygène, OH, en fait, et ça se termine par un polymère qui, en fait, on peut délimiter. Ça, c'est les bouts. Polymère. Qu'est-ce qu'on fait, en fait? On met une couleur, par exemple, chlore. Enfin, là, je dessine un peu n'importe quoi. You can say, if you have a polymer, yeah, you draw it like this. Ça, c'est en fait pour dire qu'il y a, and here we had the number, 100. Donc, en fait, this is a molecule where the motif in blue. Donc, je vais vous mettre en bleu. Color. You go to color. Or you go here. Okay. It's blue. All these motifs are 100 times. 100 fois ce motif. D'accord? Il est énorme. Donc, il est énorme. And this is a handing group. This is a handing group. C'est les bouts. OK? Si, if you have two blocks of polymer, si vous avez deux blocs de polymère, vous pouvez le dessiner comme ça. Par exemple, et dans Schiffer, c'est à peu près pareil. If you have two consecutive polymers, so chlorine is not right, but I can draw an oxygen. And you can add another motif, no matter the motif. You can, par exemple, sugar, or I can go here to a template. A template, you have different template. Advanced bio, amino acids, les acides aminés. Anatomie, ça c'est pour l'anatomie, des animaux. Aromatique. Aromatique, I told you that is conjugate, c'est la conjugaison. Multiple cycles, ça c'est les bicycles. Les objets, ça c'est pour le dessin. En fait, on peut dessiner. We can draw on Chemdraw. Okay, you have the flask. Okay, if you want to draw a flask. The tools that we use in chemistry, in a chemical lab. That's the geometry of the cycle. Ça c'est la géométrie des geometry of different geometry of cycle. I show you a few of them. What is it? So, conformer. For example, 3-member ring. That's 5-member ring. Okay. That's 5-member ring, 6-member ring. So you have all the type of Conformers, en fait, c'est les conformations, or the conformation for each cycle. Three membering, you have this one. Four membering, you can have this one, this one, this one. Five membering, you can have this one, or this one, or this one, or this one, plissé, folded. That's folded. Most of the time you find this one, okay? Six membering, like this, like a chair, or boat, okay? The blue one. Then you have, when you increase, you have different. When you have double bond and saturation, you have different possibilities. So that's why it's very powerful to use Chemdraw, because it gives you the clean the structure and respect the chemical rules. On respecte the chemical geometry. Ça permet d'aider avec le clean-up, with clean-up structure. It will help you to clean up structure. It will give you the right geometry. So I finished my story about polymers. So you have the red one, okay? So you can add a handing group. You can add whatever you want. That's just an example. You use bracket. Bracket, where is it? Yeah, this one, bracket. That means, for example, 120, okay, 120. I put it in red, I guess you can understand. Okay, go to color here, 120. And this one, you have 100 of this motif. I should say it could be a very interesting compound. I'm sure it doesn't exist. So this, you have a polymer, a block copolymer. Block copolymer. And that's, we name polymer. When you have just one block is just a number, okay? Okay, ça c'est les polymers. This is a polymer. So let's start. If you have a positive charge, you need to add it. For example, if you protonate an heteroatom, you had the CH3, you need to add. If the atom gives its electron, you have to remember oxygen has the two double bonds. If it gives one double of its non-bonding bonds to a CH3, it's positive charge, okay? You can positively or sometimes negatively. For example, OH minus is negatively charged. Okay, well, you see it's OH. So you did. So this is globally, you can clean, okay, you can clean brackets. That's, you can draw the orbitals, okay, the orbitals, this orbital. That's, you remember, for the D. I'll give you one example. You can draw, okay, whatever you want. You can draw, you can select which one you want freely, okay, what you want. That's not for chemistry, but just for a figure, okay? Yeah, this is the main part of the Chemdraw. Yeah, for example, yeah, I found it. For example, I don't know the name. Oh, I come back here, you come back to lasso, okay? Every time come back to lasso. If I don't know the name of this compound, you can go to, yeah, clean up structure to have something clean. I saw something interesting. Show stereochemistry. You can also flip it, okay? Flip. I want the name. Just me, normally it works. I can convert structure. Yeah. If it doesn't work, go to structure and click structure to name, okay? It's the same than this structure. Structure is this toolbar, okay? But if it doesn't work, go to structure and you have the name, okay? If you don't know the name, you just do that and you have the complete name, okay? And if you want to know the analysis, you go to view, analysis, and paste, okay? So this is the cyclopentane. It has 5 carbon and 10 hydrogen, okay, and the molecular weight, the weight, and the mass, how you should characterize, and elemental analysis. One more thing, okay, I hope if it's not clear, let me know. For example, you do a chemical reaction, okay, I just draw something simple. Okay, chlorine, for example, I want to do a substitution. I can add any atom I want. If I don't know which atom, you go to view, periodic table if you want to select. Okay, I want, for example, I'm not saying that, magnesium, okay, manganese, sorry. You can add xenium, but I don't think, I mean, I can add chlorine, okay, or bromine, iodine. Iodine is more reactive, okay. So I can draw it, I can type it by hand, or if you have doubt, you can click on view, show periodic table, and you select which position. It should be a blue cycle, okay, that means you can click, so no matter. Oh, so you can zoom, okay, if you want to see more you can zoom here. You can come back, you can convert it into 3D. You can add the 3D properties. You can, if you want to know the name, you go to structure, you go to convert structure to name. Why is it not working this time? Let's retry. Maybe I have a bug, but normally convert to structure to name, you have the structure. Okay, now it's off. Now you have the official name, okay? So you can pick it up and paste it on your scientific paper, but sometimes it has different name. You can iodocyclohexane. Hexane, that means it's 6. Cyclo, it's a cycle. Iodo is iodine, okay? For example, I want to do a transformation. I put here the starting material. Les produits de départ, les réactifs sont à gauche. Starting. So you have to respect, if there is something that attack, it's attack SN2, okay, it's an SN2. If you do an SN2, it's not very stable, but remember SN2 is opposite, okay, c'est un parapluie. Si par exemple on fait un OH, like this, okay, this is not stable. When it's not stable, we put it in bracket, okay. C'est qu'en fait c'est pas très stable. In chemistry, when you it's not stable because here, remember, you have a hydrogen. Tu as un hydrogène ici. So structure is not clean, okay. So you go here and you tap structure, clean up structure, clean up. Oh, ça marche pas. Normally it works. So it's not stable, and the most stable one is, you know, a version of, it's almost, that means it's displaced, okay, on the left. Then the most stable one is, you take the opposite one, you see, you invert beta rotation, and remember everything should be equatorial. OH en position équatoriale, equator E. You should look at when you have a big, this is a big one, this one has to be in equatorial, okay, that's why this is axial. And when you have axial, let me show you, okay, you have clash. Vous avez des clashs entre les deux. You have stereo clash. Vous avez des encombrements stériques. It's not good. But here, there is less stereo clash. There is less clash. Sorry, I just clean up structure. Is it working? If it's not working, well, put it like this. Oh, it's okay. Okay. Last thing. So this is starting material, and this is the product. Now this is an intermediate, and this is the product. Okay, you can align. You know, you can use like a curve object to align. Si vous voulez aligner, vous avez des outils pour vous aider à aligner. Scale. What is the scale? Yeah, that you can use this one. Rulers. It can help you to be more precise in your drawing style. So if you want like a method pour les inorganic chemistry, for inorganic chemistry, it's ion. Pour les ions, par exemple. That means starting material are on the left of the arrow, and the product on the right. Okay. So when you search on Chefender, you search that. When you don't know, you say to the software, "Hey, I want a compound," or almost. On Chefender, you say, "I want a compound like." Okay, the IUDO, you understand? I want this one. You draw it like this. Okay. Specify as much as you can. Tu dois, avec Chefender, vous devez dessiner tous les atomes. If you keep it open, that means it can be anything here, okay? He can find you many other. You draw it like this, and he will find you some. He'll give you some paper. One more thing, and last thing is the atom. For example, I want to change this one. I go to, as I said, you click here. You can change like this one, tellure. No, why not? Tellure, or you can go here, view periodic table. So tellurium is what is it? Est-ce que j'ai inventé? Did I create a new? I'm sure it exists. Ah yeah, tellurium is here. Okay. So you can like méthode transition pour les méthodes transition for les métaux qui sont ici in the middle are very important. So like zinc. Tous les métaux qui sont ici, they use this type of orbital. Les orbitales D, là. They use this type of orbital. D orbitals. They use this type of orbitals. Voilà, ça c'est les métaux de transition. Ils utilisent 5D. Ok, il y a 5 orbitales D. 5D orbitals. That's all the metal in the middle, all the one in the middle, okay? Donc c'est leur, it's the energetical level. We have 5 and 2 are above, okay? They are not necessarily equal, okay? The level is more or less like this, okay? Most of the time you have it's like this, okay? It depends on the property. Sometimes this one can go up. It depends on the what you have. For example, if you bring another orbital P, this is a P. You have a P. Okay, here P. You should respect the symmetry, okay? The symmetry. This one and this one has clash. No, not good. So you need to select an orbital. Une orbitale D où il y a le maximum de recouvrement. That means, for example, this one is a Z. If you select this one, I mean, oh sorry, I said no, it's right. You can select this one. This one is right, okay? Vous avez des recouvrements. You can overlap. Good note. Black should be go with black and no. That means, for example, the 5D, this one. va faire une liaison. How you select the symmetry is very important to make a bonding. Ça c'est le niveau énergétique. So this is a bond. Donc symmetry with metals, symmetry drives between orbitals. Drives which orbitals are involved and generate bonds. And you have, this is a bond, pi, and you have always also the magic of c'est la magique de la mécanique quantique en forme quantum chemistry. Oh, what did I do? Okay. Yeah, just an example. Okay. So that means if you have pi star, on appelle pi, pi, hein, c'est un pi, a real pi, okay, a pi star. Tac, ok. Ça c'est le doublet. It is a bond and this is an anti-bond. Okay, always you have that. Okay. So yeah, just a summary. I repeat. This is a lasso to select. This is to erase. This one is to change to type. If you don't know the metal, you can, for example, I want RG. Okay, it exists. I want this atom, for example. App. You can show the cram representation. Oh, that's not good because it's not connected. You must connect it. If it wants. Okay, like this. So if you want to make a big cycle, you can select this one. Okay, you can select this one. The number is the number of atoms you want, so you can draw. If you want to make it straight, you can make it straight. If you have ion, metal de transition, if it's negative charge, you put charge. If you want to put positive charge, you can put a positive charge. Okay. The orbitals, that's the curvature. That's the orbital S. This is S. Okay. You can add it. Yeah, you can name it. You can search for the name. Go to structure, convert structure to name. But I think the structure is so weird. When it's weird, maybe he doesn't understand. He couldn't generate. Well, you can choose to add color, blue, for example here, no matter, to show something. Okay, so this is all what you can do with Chemdraw. Okay, I hope you enjoy it, and I will make you more videos in the future. Bye bye.